So we have a problem, and it's on the topic of interfaces and object-oriented programming. So our question asks us, what does this code properly demonstrate? Is it either encapsulation, inheritance, polymorphism, or abstraction? Alright, I think it'd be sort of reductive and useless to just give you the answer. So let's instead go over these 4 topics and allow you to gain some formal understanding of what they are and then answer it. So let's try and explain encapsulation with some metaphors, okay? So here we have a stunning apartment, right? And without going into the details, let's break down some of the components in this apartment, okay? So here we have a few chairs, we have some light fixtures here, okay? And we have here a couch, and then we have this microwave here. So what is the use of actually pointing out these things? Okay. So encapsulation programming. Encapsulation is the concept of bundling data attributes and methods that operate on data into a single unit or class. And you know this to be true. I mean, you've been programming in Java in classes, right? And you've made interfaces, you've made subclasses. Encapsulation is a sort of formalized definition of what you've been doing as a program. So let me follow through this analogy here. What I can tell you is that these 3 chairs, okay, this sofa couch, this chair here, and this chair here, operate on the same fundamental idea, right? They're all a sort of cushioning or a platform for you to sit on, right? They operate on the same idea or premise, but they have different execution. Wouldn't you say that these 3 couches come from the same idea, but of course have different manufacturers? In terms of encapsulation, our goal with a chair is to, in the most formal way, and then with this idea, you can go into more specifics. How do you want to do this? Do you want to add cushioning, okay? Or do you want to add feet rest, right? What do you want to add to this fundamental idea? Okay, and in terms of encapsulation, we're bundling the idea of a chair, okay, and its attributes. So it needs to have a sort of platform to sit on, right? That's what every chair has in common. Has that platform to sit on, has legs. No chair has no legs, right? Built up of these chairs. And so the basic idea of a chair is the same, but you can execute it a different way. The same goes for these light fixtures. These light fixtures operate on the same idea of producing light, but they're doing it in different ways. Some might offer more light, right, with more bulbs. Some might offer a simple light in companion to other light bulbs. And then the microwave is its own standalone thing. You don't have multiple microwaves, you have one microwave per house. So you could say, extending this appliance idea, the fridge and the microwave aren't very different, you know? They're both maintaining temperature, right? The goal of a fridge and a microwave is to maintain temperature, but sort of a sub-specialization of a microwave is to make things hot, right? So this is the heat counterpart, and then the fridge is that cold specialization of this general idea. That's what encapsulation means for us. Now, moving away from sort of abstract ideas, in terms of actual computers, we have here a motherboard. Isolate a few parts. This could be the RAM slot. This is where our CPU goes. This is where our memory goes, or SSD, whatever you may call it. These 3 elements are standalone elements with their own attributes, own way of handling data, and own behavior. But regardless, they're part of the same design of a motherboard. So they work together. The most broad encapsulated idea in terms of a motherboard is the motherboard itself. Then you can have more deeper ideas that are encapsulated, right? So the CPU is its own encapsulation, right? So we can have sort of this formalized definition of what it means to encapsulate or bundle data, right? This is what encapsulation is. It's more of a formalism of something you already know to exist. Now, what is abstraction? Okay, what about extraction? Abstraction is really a furthering of the formalism that encapsulation offers. Okay, so abstraction in programming involves hiding complex realities while exposing necessary. And a more simple way to explain this is the same way I explained encapsulation. Okay, we had the same object. I sort of hid in that abstraction idea into my explanation of encapsulation. Okay, the same way that you encapsulate functions and behaviors of individual objects, abstraction allows for the simplification of manufacturing. Going back to the chair idea, the most fundamental chair is just, of course, the platform itself and the legs, right? That's the most abstract, okay? This is what is meant by abstraction. It is having the most high overview of a function or behavior and then fully developing it into its sub behaviors or specializations. So these three chairs are abstractions of the chair idea, but then they sort of specialize themselves. Same with these lamp fixtures and these appliances. The same follows. So abstraction and encapsulation are sort of the same, but of course different topics. But in general, they're formalized ideas of very intuitive concepts. Okay, doesn't take a PhD student to understand what encapsulation is. It's very simple. But when it comes to formally using it in your programming, that's what makes you a good programmer. When you understand how to fully abstract your methods and then specialize them, you create more versatile and more unique. And now let's move on. When it comes down to polymorphism, it's just the capability of allowing methods to do different things based on how an object is acting. So we'll take the example of a multi-tool. The multi-tool would be the best sort of explanation tool to explain this, but of course there's a few caveats. Okay, so in general, the multi-tool is exactly what it states it to be. Okay, it's a tool with multiple functionality. So the main idea you should focus on is the fact that regardless of the application, a multi-tool will have something built in it for the job, right? That's the main idea. The fact that you have pliers, as well as a bottle opener, a knife, a saw, a screwdriver, all in one package is the multifunctionality. So the main idea you should get from a multi-tool in terms of polymorphism is the multifunctionality. The fact that it can, despite its one, it's just one item, despite it being one item, it can behave and help in multiple activities, right? Now, there's a bit of a caveat. What is that? Well, the thing is, this multi-tool has all of these features built in, right? So it's up to you, the user, to choose when you want to use every item, right? Now, in terms of polymorphism, it's sort of different. In terms of polymorphism, your classes and your programs will already have known in the most general way possible, okay? So polymorphism is a saw is built for a specific case, right? Regardless of whether you're sawing wood or I don't know, piece of paper or steel, whatever it may be. The saw, the plier, the knife, these all have certain roles, right? So the knife alone, you can say, the knife alone is for cutting, right? That's what the knife is for. But you can be versatile in its usage. You can cut paper, you can cut wood, you can form it into more sharper blades and make chainsaws out of it. But the fundamental idea is that it is for cutting. Okay, regardless of what you give it, it will always cut. That's what polymorphism is. That regardless of what you've given it, as long as the main cause or the main job for the program is to do what it was made for, in the example of a knife, it can do it, okay? It's the versatility that you have to focus on. It's not the fact that it is pre-built for any task. It's that regardless of the task, so as long as the main idea is what it's built for, it can handle it. Okay, its adaptability is what you need to focus on. So that's the main word, adaptable program. Now that we have that out of the way, let's move on to our final idea of inheritance. Now, in terms of inheritance, our best analogy would be the use of DNA. Okay, now inheritance is again a generalized but formalized concept in programming, and is describing specifically the mechanism. It is not the procedure. In terms of polymorphism or encapsulation or abstraction, these are things that you inherently in the moment as a programmer make your programs to follow, right? The idea of encapsulation is to make your code as versatile as possible by bundling data, right? So things exist where they have to. That's something you do while programming. But in terms of inheritance, it is a byproduct or a mechanism that occurs when you have programmed in a specific way. And the specific way is the use of subclasses, right? The specialization, okay? A subclass is specifically a specialization of a unique or just at least a specific. So in terms of DNA, the idea is that you are coded by half of your mother's and half of your father's DNA. So in terms of your sequence of A, T, C, G, you are just a coagulation of both of their DNA. Okay? So in terms of following this analogy, a child is always a specialization of the parents, right? So the parents, in terms of occupation, might have had some jobs. This child can choose to do the same or different, right? But the thing is, they now have access to everything their parents have access to. Now that's, of course, in the simplest way, they now share a house, right? That's a very simple example. The best example would be their knowledge, right? The fact that you are very young, but your parents have lived much longer than you, right? We'll say your parents had you when you were 20, when they were 20. You have now access to 20 years of knowledge, right? So the inheritance is not the fact that you take what they have or copy what they have. It's the fact that you now have access to all of their knowledge or all of their capabilities on top of what you can do as an individual. So despite you being a new child, you have a lot more access to things than they without being too so whatever knowledge they've had, you can now inherit. The same way you have books, okay? What takes people their entire lifetime to figure out, you can read in 300 or less pages, right? So people's lifetimes, their memoirs, or their PhDs, or their theses, or what's the plural of thesis? Whatever it may be. Their lifetimes are converted to books, right? And these books would be 300, approximately 300 pages. They could be more, but regardless, the time it takes you to read these 300 or 600 or however many pages, right? It will be shorter than a lifetime, but you would have gained all of their knowledge in that time, right? So that's the idea of inheritance. The fact that once you've been instantiated as a subclass or a specialized use case of a specific feature, you now have gained the features of the superclass. With all of this in mind, what does our function do? Of course, everything I talked about was very high level, taking in inheritance, inheriting high level features. This is a very simple function, but we'll read through it regardless. We begin with an interface called flyable that has an abstract method called fly. Then we have a class named bird that implements this flyable interface, then actually executes it and defines how it behaves. The same goes for an airplane. Now, what does this actually encapsulate? Now, encapsulate, I mean, what does it actually demonstrate? I would say it properly demonstrates the idea of both polymorphism and inheritance. Now, why is that? Well, first of all, the inheritance comes with the fact that you have an interface, okay? Though this interface does not know a lot, right? This interface only gave you a abstract class, okay? It gave you a name for something and how it behaves. In other words, it gives you a void, right? So it's an executable. Okay, some might argue that that's not enough of inheritance, right? You're not getting enough from your superclass. So let's just say it's polymorphism, which I think is much easier to see because we see that both the airplane and the bird have similar functionalities. However, despite implementing the same functionality to fly, they do so in different ways. Okay, this is that specialization I was talking about. And now with that, I hope you can understand what it means to encapsulate, inherit, and be polymorphic and abstract in programming. Hopefully that helped.